Hello everyone. In this short video, we're going to look into the different number systems available. The first one is the decimal system that we use in our everyday life as we communicate between humans, and the second one is the binary that is used in circuits and also computers, as we know. And the third one is really old, and this has been used in computers and it is not used anymore. The last one is the hexadecimal that is used in digital systems such as computers, and this is one of the most important number systems that we're going to see in the future, 16 weeks. And we're going to look into how do we represent a number in each of these number system and how to convert a number from one to the other. And there is a reason why we have these different number systems. We're going to talk more about this in class, but basically I want to introduce you to these four different number systems and the different values. In decimal, as we all know, the different values in a decimal number are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is something we all know. In a binary, there are only two different values, which are 0 and 1. In octal, there are 8 different values, 0, 1, 2, 3, 4, 5, 6, and 7. In hexadecimal, we have 16 different values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we don't have 10. It starts with A, B, C, D, E, and F. And the definition radix tells us how many different values do we have in each number systems. Here we have 10 different values, so my number system decimal has a radix of 10. In binary, we have 2 different values, so it has a radix of 2. In octal, we have 8 different values, so it has a radix of 16. In hexadecimal, we have 16 different values, so it has a radix of 16. Now, let's look into a simple number such as a decimal and see how this radix relates to a simple number. Now, I'm going to look into number 7342. We know by looking at this is summation of 7000 plus 300 plus 40 plus 2, right? So this can also be written as 7 times 10 to the 3 plus 3 times 10 to the power of 2 plus 4 times 10 to the power of 1 plus 2 times 10 to the power of 0. So in other words, we are saying the lowest bit has a radix of 10 to the power of 10 to the 0, this has a power of 10 to the 1, this has a power of 10 to the 2, this has a power of 10 to the 3. And as you see, this 10 is nothing but the radix, and radix of 10. We multiplied this by 10, which is the same as our radix. And as I said, this radix represents the number of unique values in a number system. So now let's look into something like a binary. A binary, as we said, it has a radix of 2, so different values are 0 and 1. Now let's look into a number something 1010, and since this is not 1010, we have to clearly represent and say this is a binary number. So basically we put a parenthesis around it and we write a subscript of 2, which says this is a binary number. So let's look into the equivalent value. Similar to what we did here, we're going to take this number 1 multiplied by 2, this first one, plus the second 0 multiplied by 2 plus the third 1 multiplied by 2 plus the fourth 0 multiplied by 2. So 2 is a radix, so we multiplied each number by 2, and the power, we start from the rightmost just like before. This is going to be 2 to the 0, this is going to be 2 to the 1, this is going to be 2 to the 2, this is going to be 2 to the 3. So right from 0, 1, 2 and 3. This equals to 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. So this number is going to be 8 plus 0 plus 2 plus 0. So this 1010 is an equivalent of 10 in our decimal number system. So this is how we write a binary number, and we can write a decimal number and find out what is its real value.